The cost in dollars of producing X units of a certain commodity is given below. We have C of X, which is equal to 4,000 plus 9X plus 0.1X squared. For part A, we want to find the average rate of change of C with respect to X when the production is changed from X equals 100 to the given value. So the given value of the first one is X is equal to 103. So what we want to do is we want to be able to find the change in the cost in dollars over the change of units produced in X. So what we want to do is we want to find out C of 103 minus C of 100 divided by 103 minus 100. So therefore, in the first one, we're going to use 103 as the input of that function. So we have 4,000 plus 9 times 103 plus 0.1 times 103 squared minus, now the input is 100, so that's 4,000 plus 9 times 100 plus 0.1 times 100 squared. And then we're going to divide that by 103 minus 100. So we get the following in the numerator. We get 5,987.9 minus 5,900 divided by 3. And so therefore, we end up getting $29.30 per unit. Okay, now the next one is when X is equal to 101. So we're going to follow the same procedure. So again, we have the change in cost in dollars over the change in units X. So now we have C of 101 minus C of 100 divided by 101 minus 100. So again, following the same procedure, we have 4,000 plus 9 times 101 plus 0.1 times 101 squared minus 4,000 plus 9 times 100 plus 0.1 times 100 squared. And we're going to divide that by 101 minus 100. And so therefore we get the following. We get 5,929.1 minus 5,900 divided by 1. And therefore we get $29.10 per unit. Alright, so let's take a look at part B. In part B, it says to find the instantaneous rate of change of C with respect to X when X is equal to 100, and this is called the marginal cost. So what we have is C times 100 plus H minus C of 100 divided by H. So therefore, we're going to get the following. We have 4,000 plus 9 times 100 plus h plus 0.1 times 100 plus h squared minus 4,000 plus 9 times 100 plus 0.1 times 100 squared, and then we're dividing that by h. Okay, now let's go ahead and simplify this numerator. So we have 4,000 plus 900 plus 9h plus 0.1 times 100 squared, which is 10,000, plus 200h plus h squared. And if we distribute this, we get the following. We get negative, well, let's go ahead and simplify it first. So we have 4,000 plus 900 plus 0.1 times 10,000, which is 100 squared, is 1,000. And then we're going to divide that by h. Okay, now let's go ahead and distribute. So we have 4,000 plus 900 plus 9h plus 0.1 times 10,000 is 1,000. Point 1 times 200h is 20h plus 0.1h squared. Now we can either combine those values inside the brackets or just distribute the sign and then see what we can actually simplify in the numerator. So if we distribute the negative, this gives us negative 4,000 minus 900 minus 1,000. And then we're going to divide that by h. Now let's go ahead and see what we can simplify. Well, we know 4,000, negative 4,000 gives us 0, plus 900 minus 9,000 gives us 0, 1,000 and negative 1,000 also gives us 0. So now what's left is we're going to combine like terms. So we have the following. We have 9h plus 20h, which is 29h. So we have 0.1h squared plus 29h divided by h. Now if we factor out the h, we have 0.1h plus 29 divided by h, and that's and then we can simplify the h, and what we get is the following, where 0.1h plus 29, and again that's when h cannot equal 0 because of the fact that it's in a denominator. So now, in order for us to find the instantaneous rate of change, so we would say the instantaneous instantaneous rate of change is the following. So we want to find the limit. So we want to find the limit as h approaches 0 of c of 100 plus h minus c of 100 divided by h, and we found that to be the following. So we want to find out what is the limit as h approaches 0 of 0.1h plus 29. And so therefore, if we plug in 0, we have 0.1 times 0 plus 29, which therefore gives us $29 per unit.